Hey everyone, welcome back to my YouTube channel, The Creative Chemist, where we learn chemistry. In today's tutorial, we shall be starting a new series on periodic table. What is periodic table? A periodic table is a systematic arrangement of all known elements in order of increasing atomic number such that elements with the same or similar chemical properties are placed in a vertical column. I'm going to recap. I said that a periodic table is a systematic arrangement of all the known elements in order of their increasing atomic number. So that means the elements are arranged in the periodic table according to atomic number. The first atomic number to the second one to the third one and all like that. So that all in such a way that all of these elements that have the same chemical properties, they are placed in the same vertical column. So we have generally we have 118 known elements that have been confirmed. 118 elements confirmed, starting from hydrogen, which is atomic number 1, to organism, which is atomic number 118. And organism has the symbol OG, and it is unstable, it is a noble gas, and it is synthetic. All of these 118 elements I have said, some of them are prepared in the laboratory, some are natural. So we have 118 proven elements in the periodic table. The periodic table was first arranged by Mendeleev in the year 1869 to 71. So Mendeleev arranged the atomic number arranged the elements in the periodic table, I beg your pardon, based on the atomic mass and not the atomic number. And with that, some of the elements are wrongly placed, and we could not really explain isotope from that arrangement. So the modern periodic table arranged the elements according to their atomic number. So this is just a simple sample of the periodic table, where we have hydrogen, the first atomic number, helium has a second one, then lithium the third, on and on like that. So in the periodic table, we have the vertical column, which is called the group, and we have the horizontal row, which is the period. So I have GVC and I have PHR. So the vertical column, which is the group, and the horizontal row. So for the groups, we have 8 groups. Yes. From our learnings, we have 8 groups. Group 1, group 2, 3, 4, 5, 6, 7, 8. But generally, if we want to look at it, we have 18 groups. Now, I said the group is a vertical column. So I have 1, 2, here's another 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But if I am excluding all of this, then I will say group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. Now the group 1, they are called the alkali metals. The group 2 are called alkali earth metals, while group 7 are called the halogens, and group 8 are called the noble gases. So why do we have to arrange these elements in the periodic table? It's just to make our elements easy for us to learn. If we really want to learn the elements, it will be easier for us to learn. And then it's just to arrange the elements neatly so we can definitely see all of these elements. So I have said that the group is a vertical column, horizontal row is a period. So I said we have 18 groups and we have 7 periods. So, but for the secondary school, we can say we have 8 groups. Group 1, 2, 3, 4, 5, 6, 7, and 8. So, because if we would now want to prove that, then group 17 will be halogens, 18 will be noble gases. Please get it right and don't get confused. Okay, so 18 groups. Now, all of those groups, they have similar chemical properties. Every element in group 1, they have 1 electron in the outermost shell. Every element in group 2 has 2 electrons in the outermost shell. Can you see it makes it simple? Every electron in, if I say group 3, now it has 3 electrons in the outermost shell. So for you to know the group an element belongs to, so if I have potassium, okay, and you asked to what group does potassium belongs to, so you put 19, that's the atomic number. The configuration is 2, 8, 8, 1. So potassium is in group 1. And you can see that this is correct. Okay, now for the periods. For periods, once you identify the period, the number of shells explains the period to which the element belongs to. The number of shells, we have the KLMNO shell. So the number of shells you have explains the period to which the element belongs to. So we have potassium. I have the first shell, the second shell, the third shell, and the fourth shell. So that means potassium is a group 1 element and it belongs to group 4. So let's say it is a group 1 element. So this is period 1, period 2, period 3, and period 4. So to identify the group to which an element belongs to, the valence electron determines the group to which that element belongs to, and the number of shells explains the period to which that element belongs to. Good. Okay, so after we have noted that, we need to look at the periodic law. There is a law governing the periodic table, and the periodic law states that the chemical and the physical properties of the element are a periodic function of the atomic number, and that is what I've explained. The chemical properties of this element, they are a function of their atomic number. So if I want to say one of the properties of this element is that they have 1 electron in their outermost shell and they can basically lose electron. Now let's classify this element. The elements in the periodic table are classified into 3. We have the metals, we have the non-metals, and we have the metalloids. Metals, non-metals, and the metalloids. In my past videos, I explained how to identify if an element is a metal or non-metal. Now, one way I will recap for to identify that, the last number, that's the valence electron, after writing the electronic configuration of the element, symbolizes if it is a metal or non-metal. So if the valence electron is 1, 2, and 3, it is a metal. If it is 4, it is a non-metal, a metalloid. And 5, 6, 7 non-metals. So metalloids, they can act as a metal and they can also act as a non-metal. Now let's look at properties of the metal. 1, They are good conductor of heat and electricity. They are malleable. They are ductile. They make sounds. They are sonorous. Now, for non-metals, they are brittle. They are not malleable. They are bad conductor of electricity. They are not lustrous, and they are not shining. They are not. They do not make sound. So these are the properties of metals and non-metals. So metalloids can act as both metals and non-metals. Okay, there's some properties of the periodic table that we need to learn. And for us to learn the properties, there is a term called periodicity. So periodicity is a variation of the properties of the elements in the periodic table, which follows a regular pattern both down the group and across the period. What are the properties of the periodic table? Ionization energy, electron affinity, atomic radii, ionic radii, electronegativity, thermal and metallic conductivity. So these are the properties of the periodic table, and we need to learn them. What happens to ionization energy down the group and across the period? This property follow a regular pattern. If it is increasing down the group, it will increase. It is not that it increases and gets to a point and start decreasing and gets to a point and start increasing. No, it follows a regular pattern, and this term is called periodicity. It is the variation of the properties of the elements in the periodic table in a regular pattern, both down the group and across the period. I hope we got all of that. So I'm going to quickly make a recap. So we started that we have 18 groups and we have 7 periods in the periodic table, and for the secondary school you will learn that there's just 8 groups, and I've explained why we say it is 18 groups, because from scandium, which are the transition metals, scandium to zinc, which are the transition metals, then we have 1, 2, 3, 4. They are in between. So you have 1, 2, 3, 4 down to group 18. Group 1 are called alkaline metals. Group 2 alkali earth metals. Group 7, or you say 17, they are called the halogens, and group 18 the noble gases. So in my next video, I'll be explaining all of these properties of the periodic table one after the other, so we can see how it varies in the periodic table, both down the group and across the period. Please, if this video has been so helpful to you, please like, share and subscribe to this channel, and you turn on your notification bell so that when I post new lessons you'll be able to be notified. I want to thank you for everyone that has subscribed, and for everyone that is new on this channel, you're welcome. Please click on the subscribe button and follow me every time I post my new videos. Thanks for watching. Bye.